Dividing radicals. Let's say I had something like square root of 10 over square root of 2. As long as they're both underneath the square root and they're the same index, you can just cancel them. So 2 goes into 10 5. So square root of 5 over square root of 1, which is just 1. So square root of 5. Let's say you even had a number on the outside. 8 square root of 30 over 4 square root of 10. Well, same with multiplying. If they're both on the outside, you can reduce it. If they're both on the inside, you can reduce it. So 4 goes into 8, 2. 10 into 33. So what you really have is 2 square root of 3. All right, let's say if I had 10 over 15 square root of 8 over square root of, I'll just go ahead and say 2, make this one a fun one. The numbers on the outside reduce like normals by 5, 2 over 3. 2 goes into 8, 4. So we've got 2 square root of 4 over 3. And square root of 4 is 2. 4 square root of 3. I'm sorry, 4 over 3. Just thinking ahead of where we're going to go. Now, if that had been something like, I don't know, 20 that made that square root of 10, you would have been done. But since I ended up making it one with a perfect square, that's why. Well, let's reverse it. What about, because we hadn't done one like this yet, what about square root of 10 over square root of 20, where the bigger number's underneath? Well, that leaves a square root of 1 over square root of 2, which is like, here's the catch. Well, remember, as far as reducing, like if you have the answer 4/8, I always want you to reduce it to a half. Well, this falls under kind of like the same guidelines. It's making your answer final. The mathematical community never wants a square root in the denominator of your final answer. So we have to, it's called rationalize. Now, to rationalize, that just means we simply multiply the top and the bottom. I suppose it is a question, what could we multiply the top and the bottom? Because remember, if we do it to the top, we got to do it to the bottom and vice versa, or we've changed things. So what we're actually multiplying by is a fancy 1. It's just a square root over square root. So what could we multiply by to get a nice whole number? Well, square root of 2 times square root of 2. So that would be square root of 2 over square root of 4, which is 2. So if it's a square root underneath, you actually can multiply by the exact same square root every time. So like if I had 3 over square root of 5, multiply the top and the bottom by square root of 5. So 3 square root of 5 over square root of 25 or 5. And remember, if one's out and one's in, you cannot cancel. You can only cancel if they're either both in or both out. All right, let's do a messier one. What about 2 square root of 12 over 12 square root of 15? Well, I typically reduce the numbers on the outside first, and then 12 and 15, 3 goes in them. So what you have is 1 square root of 4, which you can go ahead and say 2 if you'd like, and then 6 square root of 5, and actually once we reduced that, we could reduce it one more time, so sorry about that. the one I made up. Oh well, kind of entertaining. So now the 3 down below is fine because we can have whole numbers down below. We just can't have radicals. So there's no need to multiply by the 3, just by the square root. So square root of 5 over 3 times square root of 25 or 5. And you're done. Now, let's even say I had something like square root of 7 plus 4 over square root of 3. Something like this, same thing. You can't reduce anything, but to get rid of the denominator, you'd multiply the top and the bottom by square root of 3, because remember, that's just a fancy 1. So that would give you square root of 21 plus 4 square root of 3 over square root of 9, which is 3. Now let's go ahead and just get the hardest we can. What about if they said this? Because I know you're like, oh, square root of 3, so we multiply the top and the bottom by square root of 3. So 2 square root of 3 over square root of 9, or 3, minus 5 square root of 3. Well, I've just gone from bad to worse. That didn't help anything. Well, do you remember when we were multiplying in the last video that if you multiplied by the conjugate, in other words, same exact thing but opposite signs in the middle, they always canceled. And so remember, that's just a super fancy 1, but it's just a 1. So 2 to both of those, 2 square root of 3 plus 10. Then down below, square root of 3, or 9, or 3. Now notice how 5 square root of 3, negative 5 square root of 3, on the conjugates, the outers and inners should always cancel. So that being the case, if you're doing the denominator with conjugates, the shortcut is always first minus last. So 2 square root of 3 plus 10 over negative 22. And wouldn't you know it, on the one I made up, do you notice anything about all of the numbers? Yeah, you could take a 2 out of everything. So sorry about that. We'll do a normal one next that you can't reduce anything out of, or at least I'll attempt to make one up that you can. Now, but remember on canceling, if you had something like this, you cannot cancel those because it's got to be in everything. See, this was everything. So this, there's nothing you can do. It's done. But let's do another conjugate that maybe will be done at that point. We'll say 6 over square root of 7 minus 2. Okay, we'll go for that. So since this one's minus, or we'll say plus because the other one was minus. So we'll say plus on this one. So it would be square root of 7 minus 2, because you always want to have the exact opposite signs in the middle. So the top, 6 square root of 7 minus 12. And underneath, square root of 49, or 7, minus, oh well, I did make one you could reduce, 7 minus 4, 3. So 6 square root of 7 minus 12 over 3. And sure enough, if I'd wanted to make one up that worked, I couldn't. But since I didn't want to, I did. And, you know, if they gave you something like this, which is pure overkill, but it happens, something like this, you literally just have to multiply by the conjugate just like normal, square root of 6 plus 4. But notice how up top, you're not just distributing, you're using the FOIL method. So, square root of 30 4 square root of 5, square root of 6, plus 4, all over square root of 36, or 6 minus 16. Well, the good news is nothing you can simplify up top, and that you get negative 10. Nothing you can do out. So there you go. You're done. Hope this will help to you. Have a great day.